Welcome all. Today we will see about displacement reaction. So in displacement reaction, the more reactive metal displaces less reactive metal from its solution. Or we can also say that it is a chemical reaction in which one element displaces another element from its compound and takes that place. Let's see a general reaction that A is reacting with BC. Then what will happen? A is more reactive than B, so A will displace B from its solution and it will form AC product and B metal. So here more reactive metal will displace less reactive metal from its solution. So before knowing which metal is more reactive and which is less, we should know about the electrochemical series. Electrochemical series is also known as reactivity series of metals, or it is also known as activity series. In this, the metals are arranged in the decreasing order of the reactivity. The most reactive metal is placed at the top of the reactivity series. So lithium is the most reactive metal, and as we go down further, the reactivity decreases and the platinum is the least reactive metal in the reactivity series. Here, hydrogen we have taken standard. The metals which are above hydrogen are reactive than hydrogen, and the metals which are placed below hydrogen are less reactive than hydrogen. So here the metals are lithium is the most reactive, then potassium, then cesium, barium, strontium, calcium, sodium, magnesium, aluminium, manganese, zinc, chromium, iron, cadmium, cobalt, nickel, tin, lead, hydrogen, then copper, mercury, silver, gold, platinum. So this is how the metals are arranged in the reactivity series. Let's see how to remember the reactivity series. I'll give a very important trick how to remember the reactivity series. So, lik, ba, sar, ka, na, ma, al, man, jan, kar, pe, kad, ko, ni, san, pub. Then hydrogen, copper, mercury, silver, gold, platinum. Now let's see how to remember this. So lik, ba. Lik means lithium, ka potassium, cesium, barium, sal, strontium, ka calcium, na sodium, ma magnesium, al aluminium, manganese, zan zinc, kar chromium, Fe, iron, cud, cadmium, cobalt, nickel, sun, tin, pub, Pb, lead. Then hydrogen, copper, mercury, silver, gold, platinum. This is the very easy trick. You can remember the reactivity series. By this, you can know which one is more reactive and which one is least reactive metals. Let's see with example. Iron reacts with copper sulfate solution. What will happen? So this is a copper sulfate solution and iron nail is dipped in the copper sulfate solution. So copper sulfate solution will dissociate into copper 2 plus ions and SO4 2 minus ions in the solution. So, and the iron nail, it will lose its electrons. It will give electrons to the copper ions. Copper ions are electron acceptors. They need ions to become stable. So the iron will lose electrons and this is accepted by the copper ions. And the iron will go into the solution as Fe2 plus ions. Then these copper ions, after accepting electron, they will start depositing on the iron nail as red-brown layer. So here I am writing the copper sulfate aqueous dissociate into copper ions and sulfate ions in the solution. iron will lose electrons and forms Fe2 plus ions. These ions are accepted by the copper ions and they start depositing as a brown layer on the surface of the iron metal solid. Then these iron ions which are in the solution, which are going in the solution, they will attach with sulfate ions. The positive ions will attach with negative ions and they form iron sulfate aqueous solution. So this is the mechanism of the reaction which is happening in this solution when the iron nail is dipped in the copper sulfate solution. So from here we can say that iron is more reactive than copper and hence iron will displace copper from copper sulfate solution. So iron is placed above copper in the reactivity series. That's why iron will displace copper from copper sulfate solution. So when iron nail is dipped in copper sulfate solution, the blue color of the solution will change into light green color due to the formation of iron sulfate and the red-brown layer of copper is deposited on the iron nail. Let's see next example. Zinc plus copper sulfate solution. So what will happen? So copper sulfate solution, the blue color of copper sulfate solution, we will dip a zinc strip. So the copper sulfate solution, again, it will dissociate into copper ions and sulfate ions. The zinc strip, the zinc will lose electrons in the solution and the zinc will go in the solution as Zn2 plus ions. Since the copper ions are electron acceptors, so it will accept the electrons which are lost by the zinc and it will start depositing on the zinc strip as the red-brown layer. And the zinc ions which are going in the solution will attach itself to the sulfate ions and it forms zinc sulfate aqueous solution. So here I am writing the mechanism how this reaction happens. So copper sulfate solution aqueous, it will dissociate into copper ions plus sulfate ions and the zinc will lose electrons and it will form Zn2 plus ions in the solution. It will go in the solution. These two electrons are accepted by the copper and it will deposit on the zinc strip as a red-brown layer. So this is this. Then the zinc ions which are present in the solution will attach itself to the sulfate ions in the solution and form zinc sulfate aqueous solution. So this is solid copper sulfate in aqueous, zinc sulfate aqueous, solid copper. So this is how the mechanism of the reaction. So here, so when the zinc strip is dipped in the copper sulfate solution, so the blue color of the copper sulfate will change into colorless and the red-brown layer of the copper is deposited on the zinc strip. Here the zinc is placed above copper in the reactivity series. Therefore, zinc is more reactive than copper. Hence, zinc will replace copper from copper sulfate solution and it forms zinc sulfate solution and copper. Let us see another example of lead and copper chloride. So lead copper chloride solution is green in color and we will put a lead strip in the copper chloride solution. So the copper chloride solution, it will dissociate into copper ions and chloride ions in the solution. The lead strip it will lose electrons, and since copper ions are electron acceptors, they will accept the electrons from the lead, and lead will go into the solution as lead ions, Pb2 plus ions. These copper ions will accept electron and start depositing as a red-brown layer on the lead strip. And the lead ions which are going in the solution will attach itself with the chloride ions, and it will form lead chloride, PbCl2. So hence the green color of this solution will change into colorless, and the lead strip is changed into brown color due to the formation of a copper, red-brown copper layer on the lead strip. So hence we can say lead is more reactive than copper. Lead is placed above copper in the reactivity series. So lead will displace copper from the copper chloride solution, and we will get lead chloride solution and the copper. So more reactive metal will displace less reactive metal from the salt solution. Let's see if lead PbCl2 plus copper. What will happen? Since copper is placed below lead in the reactivity series, so copper is less reactive than lead, and hence copper cannot displace lead from the lead chloride solution. Hence there will be no displacement reaction. Hence we can say more reactive metals will displace less reactive metals in from the salt solution. This is the displacement reaction. So remember, you have to remember the reactivity series. And on the basis of the reactivity of the metals, you can see that more reactive metal will displace less reactive metal from the salt solution. Thank you.